Now we're going to look at the distance time graph. The distance time graph, right? A distance time graph shows the changes in distance from a particular point with time, right? So in some cases, it can be referred to as a displacement time graph. Displacement is simply a distance with the value of direction actually considered, right? So distance with direction considered is displacement. So this shows the changes in distance from a particular point with time. So for example, let's say someone is at home, they move away from home, going to the grocery store, and they move back home. A distance time graph will be mapping how far they are from home throughout their entire journey, right? So here's an example here, right, of a distance time graph. So we have three sections here. So this is the starting point, right? This is the starting point. So this could have been equivalent to a person being at home. They move away from home to get to the store, right? And then at some point they move back home, right? So it's showing how the distance is changing with time, right? So in the first 10 seconds, right? Let me just remove these. The object moves 20 meters away from its original point, right? Because the distance is given in meters and time is in seconds. So in the first 10 seconds, the object moves 20 meters away from its original point. Then it stays at 20 meters away for the next 15 seconds. In other words, from 10 to 25 seconds, the object stays at 20 meters away. And then it comes back, right, in the next 5 seconds. Okay. So what can be done is we can find the speed or the velocity wherever the object is moving. You can calculate the speed or the velocity. So we'll split this into three sections: section A, section B, and section C. We want to find the speed of the object in the first section, in the second section, and in the third section, right? Or the velocity, right? So for the first section, we have to take our data from the first section. We need to take note of our changes in distance and our changes in time, right? So that's what we're going to do. For the first section, section A, our distance started from 0, it changed and went all the way up to 20, right? So our distance changed from 0 meters to 20 meters. So that's our D1 and that's our D2. And then our time changed from 0 to 10, right? That's 10 there. So our time changed from 0 to 10 in section A. So our time was at 0, right? Seconds. Now it went up to 10 seconds. So that's your T1, T2. Your velocity is equal to your change in distance. This delta sign refers to change over your change in time. Change in distance is D2 minus D1 over your change in time, which is T2 minus T1, right? The difference is between the times, the difference is between the distances. So this will then give you 20 minus 0, this is meters, over 10 minus 0, that's seconds. So that's going to give us, if I bring it up here, 20 minus 0, that's 20 meters. 10 minus 0, that's 10 seconds. So 20 divided by 10, that's 2. And then your result is meters per second. Meters per second. You get your units from that calculation as well. So the speed of the person is 2 meters per second, meaning the person is moving at a distance of 2 meters every second. That's how they're able to move 20 meters in 10 seconds. So that's section A. So let's move on to section B and do a similar thing. Let's investigate the changes so that we can calculate the speed. In this second section, section B, our distance starts off at 20, and then at the end, it's still at 20. So if we go to our distances, our distance starts off at 20 meters, and after some time it's at 20 meters, right? So there's no change there, right? And then our time starts off at 10 seconds, and then at the end it's at 25 seconds. So we're going from 10 to 25 seconds. So 10 seconds to 25 seconds. So this is our D1, that's our D2, this is our T1, this is our T2. What we can already see here is that the object did not move. Time moved. You can see time changing from 10 seconds to 25 seconds. But the distance is not changing. So the object was stationary. It did not move, or the object was at rest, right? So we can prove this by calculating our velocity, because our velocity again is going to be d2 minus d1 over t2 minus t1. Our d2 is 20, our d1 is 20, our t2 is 25, our t1 is 10. So this is meters, and that is seconds. So that gives you 0 over 15, right, which is meters per second, and 0 over 15 simply gives you 0 meters per second. So the object wasn't moving. You see, its speed was 0. Its speed was 0. So the object did not move for 15 seconds. Now let's look at our section C now. Section C, our distance starts off at 20 and it ends as 0. Okay, so we can go to section C. Our distance starts off as 20 meters and it ends as 0 meters. So that's our D1, that's our D2. And then our time starts off as 25 and ends as 30. So that's 25 to 30. So 25 seconds to 30 seconds. So that's our T1, T2. So let's look at our velocity. Our velocity is going to be equal to our D2 minus our D1 over our T2 minus our T1. This gives us 0 minus 20, right, over 30 minus 25. This is meters over seconds, which gives you minus 20 over 5 meters over seconds. 5 into minus 20, that's going to give us a minus 4 meters per second, right? So our velocity or our speed is minus 4 meters per second. And now you have a negative here, right? The negative sign shows that the object is now moving in an opposite direction from the original direction it was moving, right? And we can summarize this when we look at the journey, right? The journey had 3 stages, right? The object moved in 3 stages, right? The object moved a certain distance away. It stayed at that point for some time, and then it returned. So that is the summary of that journey there.